Hello everyone. Good afternoon.
Good afternoon.
Good afternoon everyone.
Good afternoon.
Okay, so back in my home country in Indonesia, specifically in Medan, North Sumatra, I once saw my mom, who has a friend who treats gangrene with a substance called chitosan. However, how could it cure gangrene? And since chitosan can be found in many arthropods, which of them has the best chitosan to be used as a gangrene healer? For this question, I made a research I called Chitosan Defies Death, and my name is FIALDY Petrejone, and I represent Indonesia. So first, what is gangrene? Gangrene is the death of tissue in parts of the body, and the treatment for gangrene are quite expensive and was not affordable by everyone, since the patient of gangrene cannot afford the treatment, they will die soon. And in Indonesia, the deaths due to gangrene are 17 to 23%. There are 3 types of gangrene: the dry gangrene, the wet gangrene, and the gas gangrene. Well, although 3 of them can cause death if it's not healed. And so, here's the problem, which is to find a less invasive method for treating gangrene, and to find the active ingredients in chitosan that can heal the gangrene, which is in the searching right now. So, the key answer for the highest amount of chitosan in an animal is the horseshoe crab. Limulidae is the only recent family of the order of Siphosaurida, which contains 4 living horseshoe crab. And the one we're using in this research is Tachypes gigas, because that is the only one we can find in Indonesia, especially near my town. In the shell of horseshoe crab, it contains chitin, which is a long-chain polymer of N-acetylglucosamine, a derivative of glucose, and can be found throughout the natural world. Chitin is also main component of many living things, like cell walls of fungi, exoskeleton of arthropods, and many more. Well, through the acetylation process, chitin then will become chitosan. This part, which is considered as acetyl, will then disappear and then will change to NH2, which is the key of chitosan. So you must be wondering why I chose horseshoe crab. From here, you can see the comparison based on viscosity between horseshoe crab, squid, and shrimp or crab. And horseshoe crab is the highest. Due to high viscosity, it means that the chitosan itself has high molecule, which means there are many nets that can close the gangrene. Moving on to the apparatus and materials. Here are the apparatus, and here are the materials. The methodology is divided into 3 major parts: horseshoe crab to chitin processing, chitin to chitosan processing, and the last is the chitosan to gel processing. The first stage is the horseshoe crab shell to chitin processing. First step is to clean the shell by removing the egg and the flesh of it. And then it was soaked in 0.5% of sodium hydroxide for 24 hours. And then the solution was changed into 5% of sodium hydroxide, immersing it for another 24 hours. This marks the demineralization process and the process of softening the shell. Moving on is to add hydrochloric acid, 5% with 5 liters of water, adding the shell and immerse for 24 hours, which marks this as the deproteinization process. After 24 hours of immersion, it was then cut, dried, and tested for acid to see whether it is a chitin or not. And as you can see here, that the mixture is clear, which marks it as chitin. Moving on to the chitin to chitosan processing, stage 2. The first step is to transfer it to the 3-net glass. Add about 50% of sodium hydroxide and let boil for 4 hours. This marks the deacetylation process. And then the shell was transferred to beaker glass, was drained, and was washed with water, and also dried for approximately 5 days under the room temperature. Moving on to the ketosan to the gel processing. First step is to crush the shell to form a powder, and then it was measured and add with acetic acid. With the ratio of 1 to 100, we can now obtain the gel of ketosan from horseshoe crab. Moving on to the procedure, it is first to clean the gangrene diabetic with natrium chloride or alcohol. Then the surface is covered with gauze, which has been poured enough ketosan gel. In this example progress, we used 2 teaspoons, and it was changed twice a day. And here are the patient's data. The name of the patient was initialized, and the age was 70 years old. And this patient has diabetes mellitus. So here are the progress. As you can see, on the first week, you can see the black marks, which marks the gangrene. And week after week, especially on the second and the third week, the discoloration which marks the gangrene has started to decrease, and new skin has started to regenerate. And finally, on the fourth week, new skin has started to fully regenerate and covered the old gangrene spot. Here are the patient statistic data. I plan to have 5 patients, but until now I have only 3 patients with 2 patients complete data, and 2 others are still searching. Patient 1 was completely healed after 4 weeks because the patient is disciplined, although the patient 2 has shown progress has shown because the patient isn't so disciplined, so it was not completely healed. So from this far, we can conclude that waste could be medicine, and that this ketosan gel has successfully healed the gangrene. Amputation, an expensive cost of medicine, will no longer be needed. And finally, my suggestion for the future is to find the combination of ketosan with other materials. Maybe there is one ingredient that can help the ketosan to work faster. So finally, my hope for the future so that gangrene patient should not suffer in amputation or to pay for expensive cost of medicine or to put in a wheelchair. I hope that they one day could have spent their time with their family. Thank you.